Professor Venus here again for chapter 4. We're going to go over the calculations with chemical formulas and the equations. What you need to know in this chapter is you will be dealing with lots of calculations, but first of all you need to know some main concepts. The first main concept is molecular mass. What is molecular mass? Is the sum, is a total of the atomic masses of all of the atoms in a molecule. We show each molecule with a formula, right? Like CH3 and H2. It's an organic compound. So when you add the atomic masses of all of these elements in the molecule, you will have your molecular mass. Of course, when we say molecular mass, we must have a molecule. This means that we are talking about molecular compounds. Remember, non-metal and non-metal. So the molecular compound mass is called molecular mass. So these are the atomic masses of carbon, hydrogen, and nitrogen. Let's say we want to calculate the molecular mass of CH3 and H2. Let's do it. We have 1 carbon plus 3 plus 2, 5 hydrogens, and 1 nitrogen. If you add them together, the molecular mass of CH3 and H2 is going to be 31.06 and be calculated in atomic mass unit, AMU. So one more time, molecular mass is for molecular compounds when we have all nonmetals in the compound, and you just multiply the numbers of the atoms by their atomic masses from their periodic table, and you will find the molecular mass. But what if you have an ionic compound? Its mass is called formula mass, because for ionic compounds we don't say they have a molecule, we say they have a formula unit. So the mass of a formula unit is called formula mass. Again, it's just for an ionic compound, and it's the sum of atomic masses of all the atoms in a formula unit. It's very similar to molecular mass. It's just distinguishing between the ionic compounds and molecular compounds. So the wording changes for ionic compound because ionic compounds don't have separate molecules. They have atoms, cations, anions, cations, anions. So we call it formula mass. An example that I wrote for you here is calcium hydroxide. Here are the atomic masses. You have 2 oxygens and 2 hydrogens. So you need to multiply both of them by 2. After you do it and you add them up to each other, you come up with 74.10 atomic mass unit. So this is how to calculate the molecular mass for molecular compounds when you have a separate molecule, and when you have an ionic compound, when you have cations and anions. Don't forget to multiply the number outside parentheses by all of the atoms inside parentheses. Alright, so let's move towards the next concept, which is mole concept. M-O-L-E, which we show only in M-O-L, mole. So basically, why do we use this concept? Why do we use mole? Because we are working with large numbers of atoms, right? There are lots of atoms in each of these elements. Then we need to put them in a smaller packages. So let's say I have some color pencils or some pens, or some crayons. I want to put them in a package or put a rubber band around them and call them one box. In order to count the atoms and molecules, or let's say just in general particles in chemistry, in order to count them better. Instead of saying just one atom, two atoms, like one by one, we put them in larger packages and we call it mole. So what is mole? The reference atom which was studied first was carbon 12. So we say mole is the amount of substance in any element, in any substance, molecular or ionic, which has the same atoms or molecules as 12 grams of carbon 12. I told you, carbon 12 was the reference. So in 12 grams of carbon 12, whatever atoms we have, we will have the same number of atoms in 1 mole of every other atom or molecule that you can say. Okay? So, the same number of atoms in 12 grams of carbon 12 is called 1 mole. Now, what is the number of these atoms or molecules? Avogadro found out this number. We show it in Na, number of Avogadro. It's 6.022 times 10 to 23 atoms. Number of atoms that exist in 12 grams of carbon 12. So you just need to keep in mind that 1 mole is 6.022 times 10 to 23 atoms. In case of molecules, it's 6.022 times 10 to 23 molecules. So we just call them particles, whether atoms or molecules. Now, the mass of these 6.022 times 10 to 23 atoms and molecules is called molar mass, which is mass of 1 mole of substance. For example, mass of 1 mole of carbon 12 is 12.01. Look at your periodic table and find the molar masses for all of the atoms you see in the periodic table. Like for sodium, it's 22.99 grams per mole. So what you see in periodic table is the molar masses for the elements, for the atoms. Okay, the larger number you see, the smaller number is atomic number, right? The position, this shows the position of the elements. And the larger number is the molar mass. So it's mass of 1 mole is the mass of these number of atoms or molecules. So, how do you calculate the molar mass of a molecule? Here in the previous page, we had the masses of the atoms that I told you. Just look at the periodic table, it's written there for you. But what if you have a molecule like HNO3, like nitric acid? The molar mass of 1 molecule is sum of the molar masses of all of the atoms. And this molar mass is shown in grams per mole. So, let's say for this example, HNO3. Let me rewrite 3 again so you don't think it's any other numbers. So, 1 hydrogen, 1 nitrogen, and 3 oxygens, right? So, the total is going to be 63.01 grams per mole. If you add these numbers, it's going to be 63.01 grams per mole. That's how you calculate the molar mass for the molecules. It's very similar to molecular mass. What is different? The unit. Instead of atomic mass unit or AMU, now you can use grams per mole. Okay? Excuse me. Now, you know the mass, you know the concept of mole, you know the number of particles, which is either atoms or molecules. You have some calculations. I prefer to classify these calculations in 3 different categories, or let's say 4 different categories. So the first category is that You sometimes in the questions you are looking for the relation between mole and mass. Okay? Whether mole is given, you're looking for mass, or whether mass is given and you're solving for mole. In this case, when you are only finding the relation between mole and mass, you will be using the molar mass of the given substance. Okay? I always say mole mass, molar mass. Okay? So let's look at this example. Let's try to find the mass of 2.5 moles of H2SO4, sulfuric acid. So we are solving for the mass and 2.5 moles are given. And to save the time, I wrote the molar mass of sulfuric acid. In the exam, in the questions, this molar mass is normally not given, but you just learn how to calculate it. Mass of 2 hydrogens plus 1 sulfur plus 4 oxygens. Okay? You just learn how to do it. It's normally not given, and I just did it to save the time. Alright, so let's do the rest of the calculations. We always start with the given value. 2.5, what is the unit? Mole. We have to get rid of mole and get to mass, which is in grams, right? So we use the molar mass. In 1 mole of H2SO4, there are how many grams? From here, 98.01 grams. You cancel mole and mole. What is left for your answer? Grams, which is the correct unit for your answer. I have the answers here, so let's see. We have about 250 grams. Okay? You just multiply 2.5 by 98.01 because they're both on top of the fraction. Alright? This is the relation between when you have mole and you are solving for mass. Let's do another example. When you are given mass, you're looking for moles. We are looking for the number of moles in a 45.6 gram sample of lead to chromate, PbCrO4. Again, to save the time, I wrote the molar mass of PbCrO4, which is normally not given, but you know how to calculate it. So, let's start with the given value, 45.6 grams of PbCrO4. You need to cancel grams, so you need to set the molar mass in a way that you keep mole for the answer. 1 mole has 323.19 grams on it, so you cancel gram and gram, and the number of moles is 0.141 mole. I started with 3 suffix, I ended up with 6 fix. Alright, so this is the first type of calculations, when you have the relation between mole and mass, whether mole is given, you're solving for mass, or mass is given, you're solving for mole. I gave you an example of each of them. Lots of calculations, but it just needs practicing. Those are not very difficult calculations. You had them before in intro chem or in high school. The second type of calculations, when you are given the number of moles, you are solving for number of atoms or molecules or vice versa. As soon as you hear the number of atoms or molecules, how many atoms, how many molecules, it should remind you of Avogadro's number. You want to see how it works? We're solving for the number of molecules in 1.78 moles of HCl, hydrochloric acid. As usual, we start with the given value, 1.78 moles of HCl, And we know that in 1 mole of HCl, there are how many molecules? This amount. 6.022 times 10 to 23 molecules. So you can cancel mole and mole. And what's the answer? It is 1.07 times 10 to 24 molecules. Okay? That makes sense because you are solving for a number of molecules and you are giving this big number, which shows the number of molecules in the sample. Alright? So you solve from mole to mole to number of atoms and molecules. Now you're ready to switch it. Let me work on an example where we have the number of particles and we're going to number of moles. Ready? Okay. Go to this example. Let's find the number of moles of 7.24 times 10 to 24 atoms of zinc. This time I gave you atom. Doesn't matter, atom or molecule, you know how to deal with each of them. So, again, start with the given value, 7.24 times 10 to 24 atoms. And you know that in 1 mole, because you're solving for mole, in 1 mole of each substance you have, which is zinc here, 6.022 times 10 to 23. In this case we have atoms. So we cancel atoms and atoms. How many moles does it give us? 12 moles. Okay? You divide 7.24 times 10 to 24 by 6.022 times 10 to 23. It gives you the number of moles. Now you know the first type and the second type. Let's combine these two types for the third type. Let's say we are going from mass to number of atoms, or vice versa, from number of atoms and molecules to mass. You cannot do it in one conversion just like the two other types of calculations. This time you need to use type 1 calculations, which is the relation between mass and mole, and type 2 calculations, which is relation between mole and number of atoms and molecules. So what was the relation between mass and mole? You learned molar mass. You would need to use a molar mass of your compound, which you normally should calculate it. And between mole and number of atoms and molecules, you will use Avogadro's number. Okay? So let's say how it works. We are solving for the number of molecules in a 3.46 gram sample of HCl. So the mass of HCl is given. You are going to change it to moles and then change it to molecules. You are going this way. Okay? So we always start with the given value. Let's do it. What is the given value? 3.46 grams of HCl. Next step is, let's say first step is the beginning of calculation. First step is to change grams to moles. How? By using the molar mass. 1 mole of HCl, if I'm not wrong, is 36.5 grams. You calculated with a mass of 1 atom of hydrogen plus 1 atom of chlorine. 36.5 grams, let's make it nicer, of HCl. So far you can cancel grams and grams. Then you go from mole to number of molecules. How? By using Avogadro's number. So 1 mole of HCl has 6.022 times 10 to 23 3 molecules. Okay, so I don't have that much space, so I will write it here. I have the answer for you. It is 5.71 times 10 to 22 molecules. We started with 3 sig figs. We have answer in 3 sig figs. Okay? Now let's go the opposite from number of atoms or molecules towards mass. That's our next example. We are supposed to find the mass of 3.83 times 10 to 22 molecules of sodium chloride NaCl. So we go from molecules, given molecules, to mole towards mass. So we go from molecules towards moles towards mass. Ready? Start with the given value, 3.83 times 10 to 23 molecules times. What do we have here? We need to change it to mole. In 1 mole, we have 6.022 times 10 to 23 molecules, right? That you can cancel in 1 mole of NaCl. Last step is to change the mole to mass. It's done by using the molar mass. Calculate molar mass of NaCl, which is mass of 1 mole of sodium plus mass of 1 mole of Cl. It's 58.35 grams. And when you do the calculations, this number times this divided by this should give you 3.71 grams of NaCl. And we started with 3 sig figs. Our answer has 3 sig figs. I hope after watching this video you are able to classify your problems. Like, this is mole to mass, this is a relation between mass to Avogadro's number, this is the relation between mole and Avogadro's number. So you need to classify and then use one of these. The last type that you will see, and you had it in your PowerPoint slides, is a little bit like digging deeper into the compound when you are looking for a number of moles or mass of only one of the elements in the compound. It's not just about the entire compound. So you will have one more extra step, one more extra conversion. It's not difficult, it's just extra conversion. Look at this example. How many grams of carbon are in 68.1 grams of sucrose, which is C12H22O11, and it's sugar, right? So you're looking for the mass of only carbon, not the entire compound. So let's see. You are given the mass of sucrose, 68.1 grams of sucrose. You need to relate it to carbon. So in 1 mole of sucrose, you need to change it to number of moles. So calculate the molar mass of sucrose, which is 342.30. Calculate it, 12 carbons plus 22 hydrogens plus 11 oxygens. So grams and grams are canceled. Now, because you're looking for a mass of carbon, you need to dive into the molecule, into the carbon. In 1 mole of sucrose, tell me how many moles of carbon do you see? I'm sure everybody sees 12 moles. Do you see that? The formula shows in 1 mole of sucrose, you have 12 moles of carbon. And now, because you're solving for grams of carbon, the end is 1 mole of carbon is 12.01 grams. So if you multiply 68.1 times 12 divided by 342.30, you will have 28.7 grams of carbon. So you see, in 68.1 grams of sucrose, you will have 28.6 grams of carbon. I hope these concepts, explaining these concepts and working on these calculations helped you understand it better. Again, I recommend, or let's say I insist on classifying your calculations onto these 3-4 types that I told you. So write down what you have, what you need, so you will find out which type of calculations you are dealing with. And believe me, it's going to be much faster and easier, and the percent of your mistake is going to be very low. In the next videos, I'm going to cover the rest of the most important parts of this chapter, which is everything is important in this chapter, very basic and fundamental.